Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 8, 2025, about 6 days ago. This paper introduces LocalSearchBench and shows that even some of the strongest large reasoning models manage only about 34% correctness on realistic local search tasks, with completeness around 77% and faithfulness roughly 62%, which really exposes how far current systems are from reliably handling everyday local decisions. The paper is titled LocalSearchBench, Benchmarking Agentic Search in Real-World Local Life Services, and the implications for domain-specific agent training are quite significant. Alright, Figure 1 contrasts three kinds of question-answering tasks that agents face. The top panel shows a general multi-hop example about SpaceX and the Oscar-winning film, where the system must chain 3 web searches to reach the director. The middle panel illustrates a local life single-hop question, simply picking the highest-rated cafe near People's Square from retrieved merchants. The bottom panel upgrades this to local multi-hop reasoning, planning both a nearby cafe and a convenience store after visiting a museum exhibition, so the agent must coordinate several steps and constraints. Well, Figure 1 focused on the logical shape of queries, and Table 1 now grounds that in real geography. Table 1 shows that the benchmark spans 3 major Chinese cities, each with many landmarks and districts, so agents must reason over rich location structure. Shanghai and Beijing each contribute nearly 300 landmarks, while Guangzhou adds a bit fewer. Together, the 3 cities cover 859 landmarks across 43 districts, which creates a dense, realistic local search space. So, while Table 1 highlighted how many districts and landmarks the benchmark covers, Figure 4 shows how the 150,000 merchants spread across those cities and categories. The top left donut chart reports that Shanghai holds about 38% of merchants, Beijing 37%, and Guangzhou 25%. The other 3 donut charts break down each city, showing very similar mixes where dining leads at roughly 35%, followed by lifestyle, shopping, and smaller shares for accommodation, healthcare, and tourism. Alright, Figure 4 described how merchants are distributed across cities, and Figure 2 now explains how those rich profiles are actually built. The left block shows seed data collection, where multi-scenario and multi-city records are sampled from a large platform. The center block illustrates data augmentation, in which a language model agent expands each merchant from 12 sparse fields into 29 detailed attributes. The right block depicts privacy rewriting and validation, where sensitive fields like names and phone numbers are anonymized before the dataset feeds the retrieval augmented generation system. Well, Figure 6 shows how local RAG turns a user query into concrete merchant suggestions. The left retrieval block embeds the query, searches the merchant corpus with dense retrieval, and returns the top N candidate shops. The top embedding block organizes all merchants as vectors in an index, which makes that fast similarity search possible. The central re-rank module then scores those candidates more precisely and selects the top K merchants. The rightmost block finally uses these top merchants to generate a natural language answer for the reasoning model. So Figure 10 turns that retrieval pipeline into a full evaluation loop called Local Playground. The top panel shows a realistic query about finding a hotel near the Bund with a kitchen and free attractions paired with the ground truth hotel list. The left block depicts the search agent, which repeatedly calls local RAG and web search tools to gather candidate merchants. The right block illustrates the validation agent, which compares the model's final answer to the golden answer and assigns scores for correctness, completeness, and other quality dimensions. So, while Figure 10 described the evaluation loop, Table 5 reports how different language models actually score under that setup, with at most 5 dialogue rounds. The table shows that adding web search, labeled Local Playground, consistently increases correctness and completeness, but usually lowers faithfulness. DeepSeek v3.1 reaches the best correctness at about 34%, yet even this strongest model still answers most local multi-hop questions incorrectly. So the big message is that real-world local search, with messy, multi-step plans across cities and merchants, remains surprisingly hard, even for top, large reasoning models. LocalSearchBench and Local Playground give a much richer domain-grounded testbed to actually fix that gap. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.